Hey guys, what's up? This is potentially going to be our last lesson of the week or of the year, to be honest with you. Pretty simple lesson. Uh, should go on page 87 for those of you that are still kind of keeping track uh, with the notebook. In terms of your final, you will have more information on your final by Monday. Monday, you will know what your final is about and what to look out for that. Okay. Anyways, it's 11.2 distributions of data. Students will be able to use the shapes of distribution to select appropriate stats and use the shapes of distribution to compare data. Very, very, very simple and straightforward. Uh, Very straightforward lesson. So let's get started, okay? Your homework's a worksheet. I've attached it. A histogram. A histogram is a graph that charts the frequency of a variable. So we want to create a histogram, okay? So frequency just means how many times something occurs, okay? So what I did here is I just numbered the red is just the same list, but just in order. Okay, that's all I did there. It's the same list, just in order. All right. And I just want to put my numbers in order. And essentially, what I'm doing is I'm making kind of like a bar graph. Okay. Over here on the left side, I'm gonna write frequency because that means how many times something occurs. Now, I don't want to make the x-axis like individual numbers like 1, 2, 3, 4, 5, 6, 7 because I don't want to list 7 through 20 numbers. So instead, what I'm going to do is I'm going to go by twos. So the first dash is going to be 6 through 7. The second one's going to be 8 through 9, 10 through 11, 12 through 13, 14 to 15, 16 through 17. Oh, God. 18 through 19, and then 20 through 21. On average, I want about like 10 bars, like 10 little dashes like that. So you can segment it. I just went by twos. You can go by threes, four, fives, whatever. I want around like 7 to 10 of these little dashes at the bottom. So however you segment your numbers, that's how you do it. Okay, so 6, 7. How many times does 6, 7 occur? One time. So I'm just going to make a bar of 6, 7 to 1. What about 8 to 9? 8 to 9 happens twice. 10 through 11 is 3 times. Might not have enough room. 12 through 13 is another 3 times. 14 to 15 is 1 time. 16 to 17 is 1 time. 18, 19 is nothing, so I'm going to leave that blank. And then 20 is 1 time. And then I kind of see this kind of curve. If I like kind of show that, I can kind of see a curve kind of forming. Okay, and that's a histogram. Pretty simple. Not really going to go into go a little bit more. We can do the same thing here. This is just the numbered in order. Here, I think, like, notice how I'm always labeling this frequency on the left side. I think here I should go by 1. So 1, 2, 3, just because I know it goes up to 7. And that's not too bad. So 1 happens 1 time. 2 happens twice. 3 happens 3 times. Or twice, I mean. 4 happens 3 times. 5 happens 0. 6 happens twice. And then 7 happens once. And that's it. That's my histogram. Right? And I can draw a little curve like that. And the reason we draw that curve is for us to kind of see like the pattern. Like, it should be a lot easier. Okay, so kind of important stuff. The shape. Okay, we want to talk about the shape of a histogram. So we have 3 different shapes. We have negatively skewed, symmetric, and positively skewed. Okay. What I would like you guys to do is I want you guys to go ahead and copy this. A lot of trig stats, the beginning of stats is you guys analyzing this kind of stuff. So it's important for you guys to kind of see it. The tail is kind of where it trails off, so this is called negatively skewed when the tail is on the left. When the tail is on the right, it's positively skewed. And the word skewed just means that it is not like in the middle. Okay, these little bullet points are actually very important too, so let's make sure we copy that. If it's symmetric, the word symmetric is important. If it's symmetric, it's kind of even on both sides. This is called a normal distribution. Okay, if it's symmetric, it has a special name. It's called a normal distribution. To be symmetric, you don't have to perfectly like be in the middle. It kind of just needs to look like it's in the middle, like as close to the middle as possible. As long as it's not for sure skewed on either side, you're fine. Okay? Okay. When a distribution is symmetric, the mean and standard deviation accurately reflect the center and spread of the data. So this is really, really important. This is the most important thing in this whole slide or this presentation. If it's symmetric, we use the standard deviation and spread or center. If the distribution is skewed, it doesn't matter if it's negatively skewed or positively skewed, we use the 5-number summary. So once again, symmetric, we use mean and standard deviation. Skewed, we use 5-number summary. Okay, so let's check this out. So I want to make a histogram. So we don't need to necessarily do this by hand. I think the homework, I don't know if it's asked you to draw one, but you're going to need to know what one looks like. So what I'm going to do here is, sorry, give me a second. I'm going to queue up the data on my laptop so I don't have to go back and forth with it. Pull up, got it. All right. So yeah, let's check it out. So I entered a site. It will be linked in the Google Classroom. So I want to determine if I use the 5-number summary or the mean and standard deviation. So I have to figure out if this thing is skewed or if this thing is symmetric. So I gotta graph out a histogram. I'm not gonna do it by hand. Let me erase all this. I'm not gonna do it by hand. I'm gonna use this site, and like I said, it's gonna be linked up for you. Okay. All right. Now, the site might have some table there. So what I'm gonna do is I'm just gonna clear everything. I'm gonna clear all my data and table, and what I'm gonna do from here, go to my data, and then from here I'm just gonna type in my numbers. So 723, and I'm gonna use spaces. 605, 847, 410, 440, 386. Smarter teacher would have had this pre-written out, to be honest with you. So that's kind of on me. So I'm clicking enter as I'm going through. I'm not going to list it as a whole line. I'm just going down, writing these numbers. So yeah, like doing this by hand would be a pain, but using your phone or your laptop or whatever you have on hand, like this makes it a lot easier. I'm almost done. Sorry, this is awkward silence. I feel like most of the video is just going to be me typing stuff, to be honest. 502, 490, 552, 390, 512, 389, 621. Okay, so that's my last number right there. Okay. I can set all this stuff. Yeah, let's just try it from here. Let's see what we can do. I'm just gonna select an all just in case something happens and this totally messed up. Nope, that didn't do anything. Okay, let's check out what we got going on here. N is 173, blah 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 blah. Update data. Yeah, I just pressed update data. And I think this should be it. Let's make sure. Yeah, this looks good. This is my data. I just have to press update data at the very end. And this is my histogram right here. If you notice that the histogram is going to be positively skewed, you can kind of tell that it trails off at the end, right? The peak is on the left. So because it's skewed, I would use the 5-number summary because it's skewed. Okay, cool. Once again, once you have all your numbers entered, just press update data, work out. What's kind of cool is it actually gives you the mean and standard deviation as well. So yeah, it kind of does it all for you. All right, we can do the same thing here. And once again, if it's symmetric, we use mean standard deviation. If it's skewed, 5-number summary. I'm just going to move on. We don't really need to worry about that. All right, creating a box and whisker plot. Okay, so the first step, like you guys should have an idea of what a box and whisker is. First step is, once again, I'm just going to write all my numbers in order. 1, 1, 1, 3, another 3. So I'm just going to write all my numbers in order. 6, 6, 2 6s. 1, 7. 1, 8. 2 9s. And a 10. Okay. So I'm just writing all my numbers in order. And what I'm going to essentially do is I'm going to find the 5-number summary. Okay. So the first thing I've got to find is my minimum, which is 1, my maximum, which is 10. And then I want to find quartile 1, quartile 2, and quartile 3, right? So quartile 2, remember, is quartile 2 is where I should start, so it's just the median. So 1, 9, 1, 9, 3, 8, 3, 7, 4, 6, 4, 6. So this 6 is it. So 6 is quartile 2. The next thing I want to do is I want to find my minimum, or my quartile 1. So I'm going to find the median of the left side. So 4, 1, 4, 1, 3, 3. So it's 3. Did I do that right? Yeah, looks good. 13 numbers. Yeah, looks good. And then I want to find quartile 3. So 10, 6, 9, 8, 8, and 9. So it's between 8 and 9, which is 8.5. So once I have that, what I'm going to do is I'm going to create a number line. And because these numbers are small, I don't have to really segment all weird. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if your numbers are more spread apart, of course, you should definitely do it more far apart, right? Spacing wise, right? Like if your numbers are like in the hundreds, you might want to go by tens or something like that. All right, my minimum is 1, so I'm going to put a line at 1, and then maximum is 10, so I'm going to put a line at 10. Then I do my quartile, so I have a 1 at quartile 3, quartile 6, and 8.5. So what I'm going to do is the 3 in the middle forms a box. The outer form a whisker, and that's my box and whisker plot. Box and whisker plot is really, really cool, is because between each little dash, 25% of the numbers are in there. So 25% of numbers. And what I mean by that is like the quantity, the amount of quantity. So what that means is if you look at this tail end right here, you notice how this tail end is bigger than the right tail end? Like they're different sizes, but within those different sizes, what that's telling me is from 1 to 3 is the same amount of numbers as between 8.5 and 10. Okay, there's the same amount, quantity-wise amount of numbers between that. It just tells me how far my numbers are spread apart. That's the box and whisker. Is it all jumbled together? Sorry, I dropped my pen. Now, ignore that. It just tells you how far the numbers are apart and so forth. Okay? And just like a histogram, we can have skewed. So you guys can definitely read all of that. It's pretty important. Okay. And then we want to describe the shape of the distribution, use either 5-number summary or that. If you want to do a box plot, once again, I have linked another site here for you. For you to play with and to mess around with. So let's check out this site. So this is for a box and whisker. So data is population or sample. Once again, we make that distinction. Let's just go sample or population. So I'm just gonna enter my numbers: 582, comma 608, 670, 620, 667, 598, 613, 537, 511, 674, 627, 674. Where the hell? Okay, 624, 627. Notice I'm not using space. I'm literally just using a comma. 661, 642, 641. You can definitely do this by hand too. It just takes a while. The next math class in stats, trig stats, you will probably do this by hand for some of it, but it's not the worst thing in the world. It's just writing the numbers in order, to be honest with you. 658, 653. Okay, so those are all my numbers, and then I'm just going to submit my data. And there's my box plot. I know it's vertical. It should be horizontal. So what I do is I switch, I rotate it. Notice on the left and right, it tells you it all, right? Notice how it says median. Remember, median is really quartile 2, right? Some of your homework tonight is going to ask you, part of it's going to ask you, hey, should we use 5-number summary or standard deviation and mean, right? And remember, 5-number summary is a thing on its own. Standard deviation, mean goes together. Like if you use standard deviation, you're using the mean as well. Okay. Some of it's going to ask you to find certain things, like 5-number summary, or find the actual mean and standard deviation. Just use these calculators. They're all here for you for a reason. Looking at this right now, it looks like it's skewed. It looks like it is skewed to the left, or negatively skewed. And the reason for that is, if you kind of look, I know it's hard because it's vertical, but if you kind of look at it, the tail, a majority of the numbers, like a chunk, like it's more spread out on the smaller numbers. So I don't know if I can draw on this, but like from 660 about down, those are like the numbers are getting smaller, right? Like more numbers are kind of jumbled there, more spread out there, because it's skewed negatively, right? That's what this slide is saying. If you're more spread out, at the tail end on the left, or where the numbers are smaller, you're negatively. If you're on the right, it's positively. Okay. I think that's pretty much all I have. All these links, all this stuff will be online. But yeah, this is going to be due on Monday. Keep a lookout for the final. Okay, the final won't be on Monday. Okay. Okay, yes. Have a good one.